Hello, good day. I'm Sir Paul, your math teacher. I'm here to help you exercise your mind to be logical, critical, and responsible thinkers. Today's lesson is about quadrilaterals that are parallelograms. This is the topic for Mathematics 9, third quarter, week 1. And without more ado, let's begin a fun and exciting lesson. In this lesson, the most essential learning competencies you will be able to learn are: first, determine the conditions that make a quadrilateral a parallelogram, and second, use properties to find measures of angles, sides, and other quantities involving parallelograms. While circles and triangles are substantial around us, today's lesson, parallelograms, for what I know, the most important and common type of quadrilaterals. And for now, I want you to look around. Many of the things you see are probably composed of some types of parallelograms. Do you agree? Do you see four-sided figures? Do you see quadrilaterals? That picture you are seeing right now was taken at Tarlac Recreational Park Playground. You can visually relate the topic in real life. Actually, many of the things you see are probably composed of some types of parallelograms. Whether it is the page of your learning activity sheet, the screen of your cell phone you are looking at, the table you are working on, or the house you are in. Parallelograms are obviously there. They are everywhere. Moreover, the word quadrilateral is composed of two parts. We have quad, which means four, and lateral, which means side. So, quadrilateral just means four sides. It is a polygon of four sides. Now, quadrilaterals have four vertices. Take note that a vertex is a point where two lines meet. These vertices can be used to name a quadrilateral. Take note also that the order of the vertices is important in naming quadrilaterals. I have here a localized illustration of a quadrilateral, and I'll be using this to elaborate important concepts you must remember. That general quadrilateral can be named quadrilateral PAUL, quadrilateral AULP, quadrilateral ULPA, or you may name it as quadrilateral LUAP. For as long as the vertices are arranged in order, the name is correct. Now, if you name that quadrilateral as PULA, then you are wrong. Why? Because the vertices are disarranged. You cannot name that as quadrilateral ALUP or quadrilateral ULAP. In naming quadrilaterals, you need to write the vertices in order. Now, you can do that clockwise or counterclockwise. You also need to master these terms: consecutive or adjacent sides. These are sides with common vertex. Using the given quadrilateral, our consecutive or adjacent sides are side PA and side AU. By the way, that straight bar or line placed above the letter is called overline or vinculum. We use that as a way of telling that we are dealing with side or line segment. Next, opposite sides. These are two sides with no common vertex. Here, our opposite sides are side PA and side LU. You may also write side AU and side PL. Next, consecutive or adjacent angles. These are two angles with common side. From the given figure, the consecutive or adjacent angles are angle A and angle U. Another possible pair is angle A and angle P, and more. Now, we have opposite angles. These are two angles with no common side. Here, our opposite angles are angle A and angle L, or angle P and angle U. So we have two pairs of opposite angles for quadrilaterals. Lastly, diagonals. Diagonals are line segments that are formed when you connect opposite vertices of a quadrilateral. In quadrilateral PAUL, diagonals are diagonal PU and diagonal LA. Did you get those important concepts? Now, master them and bear in mind those concepts, and as we progress in our discussion, you will still encounter them. Okay? A quadrilateral can have two pairs of opposite sides which are parallel. This quadrilateral is called a parallelogram. Parallelograms have two pairs of parallel sides. Now there are more about parallelograms. Now there are three special types of parallelograms, and let's start with rectangle. A rectangle is a parallelogram with four 90-degree angles. Take note of the four right angles. Now that's the definition of a rectangle. For as long as we see four 90-degree angles, now we can name the figure a rectangle. I show a 50 peso bill as an example of a rectangle, and you can see four small squares. Now that explain why the 50 peso bill is an example of a rectangle. Now you can also identify a lot of rectangles now in that 3D model. Another special type of a parallelogram is rhombus. This is a parallelogram with four equal sides, meaning the side measures of the figure are the same. Now, are you familiar with this illustration? No, that is typically seen to barrios. No, that is a bamboo fence, Pinoy style. No, you can visually see a rhombus no, in that picture. Last special type of a parallelogram is square. Square is a parallelogram with four 90-degree angles and four equal sides. Did you notice that the definition of a square is the combined definition of a rectangle and rhombus? Amazing, isn't it? No? Another picture of a fence. No? As you can see in the presentation, but here it's made of metal. No? That is one example of a square. Okay, now you can see the whole picture, no, the diagram of the three special types of parallelograms: the rectangle, the rhombus, the square, and the highlighted important terms to remember. You can pause this video lesson for more time of looking, no, but I'll be transitioning to the next part of my discussion. Okay, next is about the 5 properties of parallelograms. So help me fill in the blank, the correct answer to complete the property of a parallelogram. Ready? Alright. Parallelogram property number 1. Any two opposite sides are blank. Now, looking at the illustration, we can tell that opposite sides, like sides with color blue or opposite sides colored green, are identical, meaning they are similar in size, exactly alike, and therefore the answer is congruent. Second property of parallelogram is any two opposite angles are blank. Since we are dealing with angles, you will now look on the part of the parallelogram where two sides are sharing a common vertex, or we can simply say a corner of the parallelogram, no, you can notice, no, that any two opposite angles, no, are identical, similar and exactly alike, and therefore the answer is congruent. For the third property, any two consecutive angles are blank. Consecutive here also means adjacent, meaning in the given illustration, look for two angles, no, that are next to each other. What do you see? Can you describe it? Alright, the word that the best fill the statement is supplementary. Why supplementary? Because when you try adding two consecutive or adjacent angles, no, the sum will be 180 degrees. Parallelogram property number 4, no, is that diagonal of a parallelogram forms blank. No? This is very easy. No? This is like a piece of cake. Actually, you can answer this, no, with your eyes closed. Now, when you draw a line, segment, or diagonal in a parallelogram, no, you can form two congruent triangles. No? That's right. No? That is evident, no, in the presentation. So that's the fourth property of a parallelogram. Diagonal of a parallelogram forms two congruent triangles. For the last property, diagonals of a parallelogram blank each other. Here, we draw diagonals, two line segments in the parallelogram. Now, you can see there that two diagonals intersect, no? Meaning they meet. Also, you can notice that one diagonal divides the other diagonal into two equal parts, and therefore the word, no, that would fill correctly our fifth property is bisect. No? Diagonals of a parallelogram bisect each other. Did you get it? I hope so. Now I will give you some time to revisit the 5 properties of parallelograms. No? You may pause this video lesson if you need more time, but I'll be transitioning to the next part of my discussion. Under conditions that guarantee or make a quadrilateral a parallelogram, you need to master or memorize the properties of parallelogram that I just tackled a moment ago. Those are important concepts and terms that will help you as we continue the lesson. Now, looking at the illustration, you have there a quadrilateral ABCD with side measures 170, 179, 170, and 179 units. Notice that side measures are given and the opposite sides measured the same or are equal. Recalling the different properties we learned a moment ago, then we can say that this given quadrilateral is a parallelogram. Why? No, can you tell me what terms or concepts or property we could use to justify that this given quadrilateral is a parallelogram? Alright, we can use the property of parallelogram number 1. The given quadrilateral is a parallelogram because two pairs of opposite sides are congruent. Sides DA and CB have the same measure, which is 179 units, and side DC and AB are likewise the same case. They have the same measure, which is 170 units. Next given condition is this quadrilateral with given angles. Now we can use the idea of the second property of a parallelogram. The quadrilateral is a parallelogram because two pairs of opposite angles are congruent. No, you can say that angle measures of angle D and angle B are the same, no, which is 175 degrees, and angle A and angle C are likewise the same, which is 45 degrees. Or you can say that the given quadrilateral is a parallelogram because two pairs of consecutive angles are supplementary. No, you learned that word a moment ago, supplementary. No, when angle D and angle A are added, the sum is 180 degrees, and angle C plus angle B equals 180 degrees. Okay, here this is as easy as counting 1, 2, 3, right? Now there is a diagonal that divides the quadrilateral into triangles. Then, for sure, you know that we could use property number 4. The given quadrilateral is a parallelogram because diagonal CA divides the figure into two pairs of congruent triangles. What are those triangles? Triangle CDA and triangle ABC. If you encounter this kind of condition, know that the given quadrilateral is a parallelogram, basically because we have two diagonals here that are intersecting. What are those diagonals? We have diagonal BD and diagonal AC. Those are two diagonals that bisect each other. Now you can also notice marks or ticks, no, as we call them, that will tell you, no, that they have the same measure. I hope you can follow. Okay, so let's be more applied. No? Let's solve a problem. Now, the given parallelogram is ABCD with diagonals AC and BD that intersect or meet at point E. Now, using the given conditions on problem 1, let's solve the measure of side AB. First is to know that we are after for the side measure of AB, and then simply recall the properties and conditions we tackle. Choose one from them, no, that best satisfies the problem. No, here we could use opposite sides of a parallelogram are congruent, meaning they have the same measure. So we have AB is congruent to DC. No, change sides AB and DC, no, by their given values. 2x for AB and x plus 25 for DC. So do simple algebra, no, you get the value of x, which is 25. No, and we are not done yet because the problem is asking, no, for the value of side AB. Since AB is equal to 2x, no, and we solve the value of x, which is 25, multiply the two values or numbers, and the final answer is side AB is equal to 50 centimeters. No, don't forget the unit, no, since it is stated, no, you have to include it in the final answer. Okay, here problem number 2. The given are angles. No, you have angle DAB that is equal to 4y minus 26 degrees, and angle BCD that is equal to 2y plus 40 degrees. Now we need to solve angle DAB, or we can simply say angle A. Both are just the same angle, no, angle DAB or angle A. Now, what property of parallelogram is involved here? Okay, we can use property number 2, know that opposite angles are congruent. So we can equate the two given angles. No, 4y minus 26 is equal to 2y plus 40. Next, do simple algebra. You can use transposition method or addition or subtraction property of equality. No, those are simple algebraic techniques, no, you could use to continue the solution. Then we get 2y equals 66. So we need to isolate y. So divide both sides by 2 so that y, no, will be isolated. Now the answer is y equals 33. And no, we are not done yet. no, since angle DAB no, is equal to 4y minus 26 degrees, no, substitute the value of y no, in 4y minus 26 no, and the final answer is angle DAB is equal to 160 degrees. No? Alright, no, that's it. No? And before proceeding to your activities no, where your mastery of the lesson will be tested, you can go back no, to the discussion we had a moment ago. You may pause this video lesson. You may do so no, so that you have time to grasp no, everything no, before proceeding to your activities. But I'll be transitioning now no, to the next part of this video lesson. So now, mastery of the competency-based skills is given much emphasis in the succeeding part of this video lesson. You have more activities to perform. Actually, you have three main activities no, that are consistent with the discussion we had a moment ago no, and presented in a way that will boost your logical reasoning and critical thinking skills no. But before that no, I want to remind you no, again no, that you have to answer as truthful as you can, okay? And each item has a certain timer, a countdown timer no, that will surely help you no, demonstrate competence and exercise your sense of determination and gaining pleasure and satisfaction no, when you beat the timer no. But as I mentioned no, a moment ago, you may pause this video lesson no, if you want to give yourself more time to complete solving the problem, and that's okay. Now I titled activity 1 as Know Me for Who I Am no, because you will just simply name the given attributes, properties, or concepts no. You may choose or write as many as you like, but no, there is a note there that this is a correct minus wrong activity no. So be mindful no, in thinking of playing this safely. For example, number 1, one pair of opposite sides is parallel. So you need to visualize this attribute no, this property no, to each given quadrilateral. So you start with the parallelogram. No, this parallelogram has one pair of opposite sides that are parallel. Then with the rectangle, rectangle has one pair of opposite sides that is parallel. And then with rhombus and the square. No, you may pause this video again no, if you like to answer this now. You may do so, but I'll be transitioning to the next part of my presentation where each item will be answered. For number 1, one pair of opposite sides is parallel. What is your answer? Your 20-second timer starts now. Alright, the correct answer is none of the given quadrilateral, because each given quadrilateral, the parallelogram, the rectangle, the rhombus, and the square have two pairs of opposite sides that are parallel, no, not one pair. For number 2, two pairs of opposite sides are parallel. What is your answer? Your 20-second timer starts now. The correct answer: parallelogram, rectangle, rhombus, and square. Number 3, two pairs of adjacent sides are congruent. Your 20-second timer starts now. The correct answer, rhombus and square. Number 4. Sides are all congruent. Your 20-second timer starts now. Correct answer, rhombus and square. Number 5. Angles are all congruent. Your 20-second timer starts now. Correct answer, rectangle and square. Number 6. Opposite angles are congruent. Your timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Number 7. Opposite sides are congruent. Your timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Number 8. Any two adjacent angles are supplementary. Your timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Number 9. Diagonals are congruent. Your timer starts now. Correct answer, rectangle and square. Number 10. Diagonals are perpendicular. Your timer starts now. Correct answer, rhombus and square. Number 11. Diagonals bisect each other. Your timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Number 12. A diagonal forms two isosceles triangles. Your timer starts now. Correct answer, rhombus and square. Number 13. A diagonal forms two congruent triangles. Your timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Number 14. Equiangular and equilateral. Your timer starts now. Correct answer, square. Number 15. Sides and angles are 4. Your 20-second timer starts now. Correct answer, parallelogram, rectangle, rhombus, and square. Yes, you can. That's the title of the second activity, where is asking you to give what is missing or equivalent element that will make the mathematical statement correct. Moreover, you are going to solve for the asked values and measures. So writing your solution is highly needed. Now, we had similar problem a moment ago. We solved them. And I know you can perfect this problem. Okay? Again, you may pause the video if you like to answer this now, but I'll be transitioning to the next presentation where each item will be answered. Given parallelogram MOVE, where diagonals MV and OE intersect at X, complete the mathematical statement applying the given property of parallelograms for each item. You have 10 seconds to answer each item. Number 1. Applying parallelogram property number 1, side EV is congruent to blank. Your 10-second timer starts now. The correct answer is side MO or side OM. Number 2. Parallelogram property 2. Blank is congruent to angle EVO. Your timer starts now. Correct answer, angle OME or angle EMO. Number 3. Parallelogram property 3. Angle M plus angle E equals blank. Your timer starts now. Correct answer, 180 degrees. 4. Parallelogram property number 4. Triangle EVO is congruent to blank. Your timer starts now. Correct answer, triangle OME or triangle EMO. Number 5. Parallelogram property 5. Blank is equal to line segment XE. Your 10-second timer starts now. Correct answer, line segment XO or line segment OX. Given parallelogram NICE, where diagonals NC and IE intersect at U, side NI equals 3x minus 5 feet, side IC equals 2y minus 7 feet, side CE equals x plus 7 feet, and side EN equals y plus 3 feet. Question: what is the value of x? Your 30-second timer starts now. Alright, so after reading the word problem, the given, a good first step is to draw or illustrate the problem and then label it. Once you have got a useful drawing or illustration, the solving is usually pretty straightforward or easy as 1, 2, 3. That's a useful technique. Okay, so we have here the drawing. Since the given condition could tell that sides NI and CE are congruent, then equate its given measure. Side NI is congruent to side CE. So the value of NI is 3x minus 5 and CE is x plus 7. Equate the two, do simple algebra. You can use transposition method or addition or subtraction property of equality. Those are simple algebraic techniques you could use to continue the solution. Then we get 2x equals 12. Isolate x by dividing both sides by 2. So we have 2x divided by 2 equals 12 divided by 2. And we get x equals 6. Question number 7. How long is side CE? Your timer starts now. Okay, so since the solved x value is 6, then we have x plus 7 for side CE. Substitute the value of x which is 6. So 6 plus 7. So side CE is 13 feet. Question number 8. What is the value of y? Your timer starts now. Okay, to solve for y, we have side AC is congruent to side EN. Equate the values to y minus 7 and y plus 3. So do simple algebraic technique. You can use transposition method or addition or subtraction property of equality to get the value of y, and the final answer is y equals 10. Question number 9. How long is side EN? Your timer starts now. Okay, so since the solved y value is 10, then from the given, En equals y plus 3. Now substitute the value of y. So we have 10 plus 3. The final answer is side En is equal to 13 feet. Question number 10. Solve the perimeter of parallelogram NICE. Your 30-second timer starts now. Okay, so to find the perimeter, add the lengths of all the 4 sides. So perimeter is equal to side NI plus side IC plus side CE plus side EN. So we have P for perimeter, and we have 13 feet for each side. Therefore, the perimeter of parallelogram NICE is 52 feet. Now, in activity number 3, follow your inner voice. Start thinking from the top of the flowchart. That will direct you to a specific shape. But first, you need to correctly imagine the figure. Feel it so you could arrive at the correct figure. Your answer here is a drawing. So you will draw. Now, you may refer to your learning activity sheet on page 6 if you find the statement hard to read. And you may pause the video if you like to answer this now, but I'll be transitioning to the next presentation where each item will be answered. For the first drawing, look at the flowchart. So let's start at the top. It says start here. And then we move down. Does it have 4 right angles? If it is no, are opposite angles equal? If it is no, are 2 sides parallel? If it is no, are the diagonals perpendicular? And if it is no, what figure can you draw? Draw your answer. Your 5-second timer starts now. Okay, the correct answer is a general quadrilateral. So your drawing may vary. As long as you draw a general quadrilateral satisfying the given statements, your drawing is correct. Number 2. Okay, let's start here. Does it have 4 right angles? If your answer is no, are the opposite angles equal? So let's say yes, are all sides equal? If your answer is no, what figure can you draw? Draw your answer. Your 5-second timer starts now. Okay, the correct answer is parallelogram. Next, number 3. Start here. Does it have 4 right angles? If your answer is no, are opposite angles equal? If it is yes, are all sides equal? And if it is yes, what figure can you draw? Draw your answer. Your 5-second timer starts now. The correct answer, rhombus. Number 4. Start here. Does it have 4 right angles? If it is yes, are all sides equal? And if it is no, what figure can you draw? Your timer starts now. Correct answer is rectangle. 5. Start here. Does it have 4 right angles? If it is yes, are all sides equal? And if it is yes, the figure is, your timer starts now. And the correct answer is square. Lastly, for your performance task, you will reflect. You are guided with these questions. If you are done with all the activities, what are your thoughts about the overall lesson? Is it interesting? Did you enjoy it? Did you discover new things? And how do you apply what you have learned in life? And I'm excited as always to read your insights, okay? And that brings me to the end of this video lesson for Mathematics 9 Week 1 of the 3rd quarter. Thank you so much for watching and learning with me. I know you got something useful, and whatever it is, you are now better than a moment ago. I'm Sir Paul. Till next time.